Okay, so what of these batteries here? What are we going to do with those? Well, we could go ahead and stick one more on here. But I think since these are working, we should just keep them to the side. And if we have one of these other ones go out, then we can just cycle it in. I'll give you an example here. I'm going to run the fan again. Okay, now let's take a look at these while they're running with the voltmeter. This one here is giving us 12.5. This one here is giving us 12.5. This one here is giving us 12.5, and this one here is giving us 12.5. Well, that would be what you would expect if you really understand what parallel is. They're all connected together. So it's getting about what it's reading up there. There's a minor difference. What you really want to know is what kind of current each one is putting out. And so if you have a clamp meter like this that measures DC current, this makes it really easy. So we're going to go to DC current here and zero it, and we're going to look at this battery here and see that it's putting out about 1.7 amps. That's not a whole lot. This one here is contributing 1.5. This one here is contributing 1.3, and this one here is contributing 1.5. So we don't have a great load on it right now because altogether these aren't drawing more than about 5 amps. The fan's running about 50 watts. So we're going to kick it up a few more notches. All right, now we're drawing a little more power, and we'll look at it again. 2.4 amps, 2.0 amps, 1.8 amps, and 1.5. So this one here, at 2.5 is the strongest one. Well, that's also the one that measured the strongest, 74 amps. So not too unexpected there. But this one here is the lagger of all of them, right? At 1.8, sure, okay. Well, let's grab this other one here that we got, this 47. And we'll just go ahead and disconnect this one since it's not really doing much for us. Notice everything is still running. Whoa! I'm going to go ahead and change that cell out. All right, now let's see what we have. 3.3, 1.7. Well, it looks like 1.2. The one we change out isn't doing a whole lot more. And 1.5. But you can see how you can change things out on the fly like that, which means that you can run around and do maintenance on them. So I can take this battery offline right now. My inverter is still running, the green light is still on. And I could actually give it a boost from the ReVolt. By plugging the ReVolt into the battery here, into the inverter. I'm going to go ahead and use these other batteries to help push the power level up on this one a little bit. Let's turn it on. Okay, now the ReVolt is running off the inverter, which is running off the other 3 batteries here. And I'm going to go ahead and give it a little manual shot, again because these are so small. And there we go. These other batteries are actually running it. Now, we get an idea of how long it's going to last? Sure. We can look at the total current coming out here by just going over one of these rails here and see that it's taken in 3.8 amps. Well, these batteries had originally a capacity of 5 amp hours. 3 of them probably ought to go an hour at 5 amps. So we should easily be able to do a half-hour kick here with the ReVolt on this. But again, I do have this other one over here, and we have these other 2 in fact. We could go ahead and check them right now. Let's see where they're at, see who the strongest is. The one we took off was originally rated at 47. And we've got this one here that we were getting 26 out of before. So finicky on this tester with these connections. All right, 24 amps, pretty low. Let's check this other one. $52 amps. I think we must have mismeasured it before. We had, oh, actually, no, we didn't. 55 amps. I thought it was 35 when I looked at it before. So this would probably be a good one to put in place here. Give us a little extra capacity while we're running. I'm just going to go ahead and throw it. Right now, we're down to 2.2 volts back here on the whole grid. Or I should call this an array. Oh, we jumped up to 12.3, so I'm sorry, I meant 12.2. So that battery's actually helping out. And like I said, I just threw that in there so you can see it. Sorry, it was off camera. While we're continuing to use the inverter and do something useful with it. But now, let's suppose we get a different battery in. This particular clip, I did not record the audio track because the microphone was dead and I was unaware of it. So this is a voiceover to just explain. I'm introducing this new battery here that's from the shop, and the next clip in a few seconds will have an audio track that I recap what's happened because I realized the microphone was off, and we'll explain it then. So just be aware this is the battery coming in and the explanation is going to follow. So the audio portion of this was off the whole time. Let me explain what happened. I couldn't get any more small batteries to test this with, so I went to the shop and got one of the fresh intakes that came in from a customer dead. It's a 2012 battery. It originally read 4 volts with the voltmeter. You saw me do that. We don't have enough time on the energy that's in the array right now to actually do a full revive cycle, because as I said before, a revive cycle on a battery like this can take 6 to 30 hours, and there's maybe, at the current rate that this thing's drawing power, there's maybe an hour left in the charge on this array before it needs to be charged again. Again, I'll show that. It's currently pulling 4.9 amps right now. So it's going to take it down quickly. Hopefully we'll get a 30-minute pass out of it. We can see some improvement, and then we'll have to simulate another day's worth of charge on the array to run it again, and maybe multiple times to step this up. However, once we have this battery up, we can add it to the array along with these other little batteries, and that'll give us quite a bit more capacity. And then the next battery we can run even longer. So it's worth making the step here if we can do it. We're down to 12.2 on the array voltage right now, and yeah, we'll go ahead and stop it here then. I almost forgot too, again, to show the advantage of the flexibility of this. We do have these other 3 batteries over here that we said are still good. So if we get close to the time on this and it looks like we're getting low on energy, we'll go ahead and try to swap some of these out to keep this going and maybe complete the cycle, at least, of the 30 minutes here. So we'll keep our fingers crossed on that. Okay, well, we've made it to minute 22. We're up to 12.4 volts. That's a good sign, but it'll probably fall back when it's done with the treatment. So we'll have to see what it falls back to. I just saw it bounce back to 12.1 real quickly there on that delay. But I think it's probably going to complete because the array voltage is 12.1, and we still have about another 1.1 volts we can go down before things get really dicey. So I think it's going to complete this 30-minute cycle, and then maybe we'll try another one. Again, we have these other 3 batteries here with charge on them that we can cycle in and see if we can get through it, and we'll see how far we get with the battery. All we have to do is bring it up to a level that it can be charged. Once it can be charged, then whatever's charging the array can charge that battery as well. So that's where we're at. All right, we actually made it through. The array voltage is showing 12.2, 12.1 between the two, but I noticed it was 12.0 right before it stopped. It's showing 11.8 volts on the battery. That's not where it needs to be, but let's see what the meter says on it as far as what its capacity is. Well, it's lighting the meter. It's much better than it did before. It's just a regular flooded. Well, it's 11.7 volts and thinks it has a 15 amp cranking capacity, which is probably right given the fact that it's an 8-year-old battery. It was dead as a doornail when it came in. And so we're going to go ahead and try to treat it for another 30-minute period here. And see how far the array holds us. Use the same settings, wave 3, 30 minutes. The array voltage started at 12.0 now, and again it is drawing 5.1 amps, so it's giving it a lot right now. And as I said before, when we get down low, we'll start swapping some of these batteries out and see how far we can get before all of them are depleted. And then go in for another charge cycle. So we had a bit of an event here. The array fell below a certain voltage and it cut off the ReVolt. I had to reset it. I'm not sure what that voltage is, but you might notice that I've got a kilowatt-hour meter on the output of the inverter now, so I can watch the line voltage. Right now it's reading 118. The array voltage is reading 1.18. I've restarted the ReVolt. It was probably had about 4 minutes left of the 30-minute cycle. So I'm going to run it 5 minutes here. And in the meantime, I'm going to go ahead and check these batteries and see if it's maybe time to switch one out and get a little longer run time out of them. So we've got this one here is giving up 1.2 amps. This one is giving 1.7 amps. This one is providing 1.4 amps. And this one is providing 1.2 amps. So the one on the beginning or end one, we'll go ahead and plug this one in first before we disconnect the other one. That's why we have this extra lead set here. And let's see, are we jumping up when we do that? Yeah, we're going up a 0.1 volt when we do that. So let's go ahead and disconnect this one here now. Got this one over here that we will plug in next when we get down to, I guess when I see it down to 11.6, now it's back up to 12. So plugging that other battery on helped quite a bit. Back down to 11.9 though. It's better to keep one in reserve and add it when you take one down than the other way around, because then you're letting the array drop in voltage before you switch voltage in, and it might cross over some threshold that you don't want it to go into when it does that. Of course, this whole thing, as I mentioned before, is very, very dangerous. You sure as heck wouldn't want to drop a wrench across there. Of course, it's 12 volts, so unless your hand's wet, it's not going to be a problem. The other issue is if one of these leads comes loose and reaches across and touches the other side. That's going to generate a big spark and probably a big glowy wire, which could cause a fire to get burned. So don't recommend this type of construction or this lack of protection for a device like this, but you can see how simple it is and how effective it is. And if you want to build yours that way, that's up to you. The construction of it is pretty obvious. The main thing that this is for is to demonstrate the value of the ReVolt for a system like this, because again, when you can pick up batteries for just pennies on the dollar because they're discarded and dead, and you can make them useful again, even if they don't have all of the capacity, even if they're only 30 or 40%, as long as you've got room underneath your farm, they are a contributor. And as long as they take a charge, they'll discharge and give power back. And that's all that matters. So we'll see when we're done with this battery here, it may not, for example, have enough power to crank an engine over, but it might be very fine to go ahead and add to the Scavenger farm, as it might end up replacing 2 or 3 of these little batteries all by itself. Down to 11.8. We are up to 5 minutes though. So if I would have been on the ball and knew exactly what the cutoff time was, I could have replaced that and saved probably the brownout that happened to it. All right, so we're going to call the test completed, and we're going to go ahead and take a measurement at this point, at which point we will then probably start another cycle. So last time we put the meter on it, we got a 15 amp capacity. The voltage was 11.7. See if it's a little higher this time and a little more capacity. Regular flooded. Cranking amps. It's currently 11.8 and 19 amps. So it's going to be a slow crawl up this hill, I can tell. Although again, at this point it may take a charge, and a bulk charge would charge it much faster than the ReVolt will charge it, because charging is only a side effect of what the ReVolt does. So actually that was 11.9 if you round it up. 11.9 and 18 amps. Okay, we'll start another cycle here. Now I could lower the time. You see that's settable on it. That would give me a little more opportunity to come in and check and make sure we're not getting too low. But I see already that we're down to 11.8 volts. And that's, I think, near the sketchy region for this inverter. We're still putting out 118 volts AC, although it seems to be varying a little bit. Okay, the array is down to 11.6 right now, so I'm going to pause it. Let it jump up a little bit here, and let's see who we should eliminate next or swap out. All right, I'm going to start it again just so that it has a load on it and I can see the differences. Point 7, 1.5, 1.1. Okay, and this one back here, 1.7. All right, we're going to take this one off here. Again, we're going to pause it. This one in. Right now we're at 11.8. I put this one on. We jumped up to 12.1, so made a good move there. All right, we're going to go ahead and continue it. And now it's at 11.9 at least. So we'll check it again in a few minutes. That's all. All right, well, we're just about there. I've also got a blinking light on my wireless mic, so I'm going to have to charge that as well. We're at minute 29 of 30, and the voltage on the battery has come down a little bit. That will happen, even though that's counterintuitive. It's because as it desulfates, it clears plate area away, and as I said before, the process doesn't necessarily give it that much charge. So if it clears plate area way faster than it's giving it charge, the voltage will fall. In fact, it just is clicking between 12.2 and 12.1 now. Anyway, it's now on minute 30. Our array voltage is 11.7, and I think it'll finish up this round, and then we'll probably be toast. I don't believe I have, well, I do have one more battery left I can switch in. That may get us another 30 minutes. Not sure of that. But That should be done in a minute. We'll give it a quick test, and hopefully we've made some improvement. If not, then we'll go to a higher wave next time. There we are. We're done. Okay, array voltage is 11.9. I'm going to turn this off. And let's take a look at this. Okay, it says it is now reading 24 amps and 11.9. So the voltage is the same. It was reading 11.9 last time. Well, pretty close. Rounded up, it was 11.9. Still 11.9 and 24 amps. So that's a pretty good jump from last time. Although we need to be way, way up there, much higher than this. We need to be in the hundreds, hopefully. So. We'll go ahead and charge the array now at this point, and then when it's charged we'll run over this again, except we'll go with a higher wave. So I guess we'll be doing this tomorrow probably. Okay, it is the end of the day, shall we say, in theory. The solar panel has finished charging the grid, and we're back up to 12.9. We have, or I mean the array here. However, I'm going to go ahead and disconnect this one here because this is our extra cell, so we're starting out back down to 4 again. And now we're going to go ahead and see where this guy ended at. If you recall, last night it ran for one cycle, or no, 2 cycles actually, according to the paper here. So we're going to see where it's sitting now. It's not uncommon for them to fall down over a period of time, especially when they're not fully recovered, because some of that internal parallel parasitic resistance is still there and can bring them down. So let's see what we have right now. We have this is a regular flooded, and it is showing right now 6.93. So it fell back quite a ways. I think last night it ended at 11.9. Right. Okay. So it's lost some charge, but it's been sitting here all night, and like I said, we didn't complete it. So we're going to go ahead and start another pass on it, and we'll go ahead and turn our inverter on and turn our ReVolt on. I don't anticipate 30 minutes with a freshly charged array here being any problem. So we'll go ahead and put it back on manual. 30 minutes. We'll go to wave 3 and let it go. And we'll come back and check it again in 30 minutes. It did start at 2.6 and 0 when it was first brought in here. So it's already made some progress, and it's holding some voltage for some time.